I'm Liz Hill. I'm on the business development team at Formlabs. I may have seen a few of you in previous sessions. Thanks for joining again. And today's session is Tinkercad for Jewelry. Will be an overview and tutorial. And this is part of our ongoing series, which is Formlabs Comes to You. So if you haven't joined us for some of the jewelry content that's been happening throughout June. I just want to sort of mention and call out that we are doing a full month of June jewelry programming, which is really sort of in place of the big jewelry exhibition JCK that normally happens in June. Formlabs wanted to do something to really speak to our jewelry customers and interested new customers. So I will point out some of the content that we have done so far, and that's upcoming, again, throughout the month of June. So last week I had hosted a former colleague at Coach, Deborah Green, who walked us through really a wonderful tutorial in Rhino for jewelry. We also have a ZBrush demo coming up with Tomas Wittelsbach, who is an amazing digital sculptor. So he'll be walking through ZBrush. And then I also wanted to invite you to a panel discussion, which will happen next Thursday at noon, same time, which is a conversation that I will be moderating between Rio Grande and GIA. That is really sort of an overview from education to fabrication. So really the professional's guide to jewelry. And so if you want to check out anything that you haven't seen that you might be interested in, definitely go to formlabs.com. We have these, all of these webinars available on demand, and you can certainly sign up for anything that is upcoming. So we have additional 3 design demos, Tinkercad today, and then I believe Blender was a couple weeks ago. So definitely check those out. So before we get started, there'll be a live poll that will come up on screen. So if you can just take that poll, a couple questions so that I can kind of understand who the audience is, what your level of comfort is around CAD softwares, 3D printing. And then while you're taking that poll, I will just remind you to be sure to answer, or I'll answer questions. Be sure to ask questions all along the way as they sort of arise for you. And if you want to ask a question, please do that by using the Q&A button that's at the bottom center of your screen. There is a chat area, but we're not going to be monitoring that for questions. So just be sure to drop those into the Q&A. And then at the end, we will, I'll try and address as many of those as possible. So we'll get that poll going. I'm just going to wait for the results of that to pop up. Okay, great. So it looks like we have the majority of amateur hobbyist jewelers, which is great to know, some professionals, thank you for joining, and then some non-jewelry folks, which is awesome. And then wonderful. So a lot of you are looking around, still learning about CAD software. Some of you have never tried it, and then a few pros here. So that's great to know. And then most of you, it sounds like already, or about half of you or so already have 3D printing in your workflow. So, all right, wonderful. So thank you for that. Now I kind of know more who I'm talking to. So yeah, let's get into it. So the agenda for today. I'll do a little bit of an introduction so that you have a bit of background on me. I will then be kind of walking you through a broad overview of Tinkercad, what it's used for, how you can kind of get started, and why you would start here. And then I'll dive a little deeper into universal best practices for 3D modeling, sort of through the lens of a review of a skull ring that you saw on screen right as you were joining. And then I will sort of quickly talk to prototyping and production for those of you who are new to Formlabs or new to 3D printing in general. I'll give you an overview of some resins that you'll want to kind of be on the lookout for try out, and then sort of show you briefly preform if you're not currently familiar with preform. And then I will do a live demonstration modeling a script ring to sort of really get you a sense of what it feels like to be in the Tinkercad environment. And then we'll wrap up with some resources for continued learning and then move to a Q&A. So we should wrap up a little bit before 1 p.m. Okay, so just a bit about me, just to kind of give you a sense of where I'm coming from, my background is. So prior to joining Formlabs, I spent 15 years in the fashion industry professionally. About 8 years of that was, the recent 8 years of that was using Rhino 3D professionally. My previous role was Director of 3D Prototyping at Tapestry. So anyone who doesn't know Tapestry, you may recognize some of these images on screen. So these are Coach, Kate Spade, and Stuart Weitzman were the brands under Tapestry. So I started with Coach, and then we became Tapestry. And my team, the team that I oversaw, was really responsible for the 3D visualization for fashion hardware and jewelry. So really all these metal components that you see on these accessories and the jewelry, these are examples of the work that I did using Rhino. So then you might wonder, why Tinkercad? How Tinkercad? So for me, I discovered quite a few years ago that actually Tinkercad was out there and was something that I could really use as a tool to educate younger people and also just anyone who's new to 3D modeling, who's interested in getting involved, learning 3D modeling, but may not be ready to make a big sort of, larger financial investment, time investment into learning one of the more robust CAD softwares. So I started teaching Tinkercad through partnering up with an organization called Tech Girls. And Tech Girls is a Philadelphia-based nonprofit that rolls out curriculum for anyone who's looking to get into sort of STEM-based programming. So I approach this from the point of jewelry, since that is my sort of background. And some of these examples on screen, well, all of these examples on screen were modeled in Tinkercad and were some of the curriculum samples that I had developed for them that are still taught today. I've also taught workshops for Girls Who Code, Tech Girls, as I mentioned, and then more recently as part of the Maker Mind program at FIT, which is where I went to college as well. And then I will talk a little bit more to these live streaming classes that I have online through my YouTube channel. So if you are interested in jumping into Tinkercad, specifically for jewelry, I have 5 classes that I offered through the month of April, just as a sort of way to offer up some design and some tips for CAD. So what is Tinkercad? So Tinkercad is made by Autodesk. And Autodesk, if you're not familiar, which I assume many of you are, is a very large company that's been around for decades that is sort of the leader in terms of the amount of CAD CAM softwares they offer. So they do a lot of professional industry platforms, but they do own Tinkercad, and they offer it to their users for free. So all you really need to do is sign up through tinkercad.com or autodesk.com for an account, which is just your email. And then you really have access to this browser-based interface, which we'll be walking through in a little bit. And this is really a very easy to learn, intuitive interface, perfect for beginners, for children alike. Most of the classes that I teach to middle school students and high school students. So really, anyone can really pick this up and get into it with quite a bit of ease. And the basis of Tinkercad is not that different from more robust professional modeling softwares. You use primitive shapes to create more complex designs. And so this example on screen, you can see the top image showing the Tinkercad rendering, and then you can see it casted in bronze here, and then the finished piece that I'm wearing. So you can really see that you can really achieve very detailed, true, custom design jewelry using this otherwise very simple to learn software. And the beauty is that it does allow you to very easily export 3D printable files, and I'll kind of walk you through that towards the end. So jumping into universal best practices. And what I want to really say here is that the beauty of learning Tinkercad to get started is that the habits that you learn here and the sort of modeling principles can be applied to other modeling softwares. There's a lot of different types of modeling softwares out there, but the sort of practice of 3D modeling is the sort of principles and best practices are very common throughout those softwares. So you can learn them here in a sort of lower stakes environment, and then you can apply them later if you decide to evolve your own CAD ability. So the first thing I'll kind of mention is that fabrication is really something that you'll want to keep in mind when you're learning any CAD software and when you're starting to use CAD. Fabrication informs the design process. So what do I mean by that? So you'll want to think about some of these prompts that I'm giving you. What materials are you using? Are you going to be using to fabricate? So when I say that, I mean that metals, right, have different tolerances than resin. If you're ultimately fabricating in metal versus resin, you'll want to design your part differently. So think about wall thickness, lightweighting those parts, reducing the material cost, reducing the density if you're making this in metal. You know, if you're making this in plastic or a resin versus sterling silver, the costs are much different. Are there size-dependent elements in this design, in your design? So consider the editability of features. Items like ring size, chains that you might be attaching, ear wires, jump rings, excuse me. These are all the types of things that you will want to think about when you are when you're building your model. If I'm building something that has a size 6 ring size, what if I have a customer that's a different size than a size 6? What if I would like to size it up for myself? Thinking about how can you make your model as easy to edit as possible down the road if you need to. How will you fabricate this item? Are you 3D printing your part? Is that going to be for design prototyping, or is that going to be used for casting? Do you have a casting house? Are you a caster? Do you need to add sprues to your part to be casted? Work with your manufacturer, check with your manufacturing partner, or use your own sort of knowledge around traditional manufacturing methods to determine what considerations do you need to make when you're building the design, right, in CAD. We're talking about jewelry, so obviously stones, right? Will stones be set into this piece? If yes, do you need a bezel? Do you need to add prongs? Do you need to seat those stones? Do they get drilled out? These are all the kinds of questions that you'll need to have answered for yourself and be thinking about when you're approaching your design process and when you're learning CAD. So this is the most important. If you take nothing else away from this entire presentation, this is the most important thing, and this is universal for all 3D modeling softwares. Define and know what your modeling strategy is. I used to lead a team of 5 people who were all very talented CAD designers, CAD artists, with a focus of jewelry. Whenever they ran into trouble, meaning that they were working on a design, working on someone else's, an internal customer's concept, and they were having a challenging time sort of translating that and really realizing that in Rhino or in their 3D modeling software. Oftentimes, they were struggling because they didn't really have a strategy. They didn't really think, all right, how am I approaching the modeling process? And so these are some, again, prompts or questions that you can ask yourself that will help you define your modeling strategy. So the first and most obvious yet often unasked question is, what should your model look like when it's done? Do you know in your mind or on paper what your model should look like? What does that design look like from all sides, all angles? If you don't know this, it's going to be really hard to figure it out as you go. The order of features. So what modeling order? So order that I build out my shapes and my features, my components that make up my model. What order of 3D modeling will allow for the greatest flexibility and editability? So we talked earlier about that ring size, right? So things that are likely to be modified, to be revised in some way. Build your model in a way that provides you ease later down the road when you have to eventually go back and make those changes. Plan for revisions. Sort of that same statement, right? So this was a huge part of the past decade of my life, really, when I was working with designers at Tapestry, where they would give me ideas, and that usually came through sketches, through reference images, through vintage samples, and I had to do a lot of interpretation. The whole process of taking a idea or a sketch and translating it over to a three-dimensional model, that is literally loaded with interpretation. So plan for the revisions and make your life easier. And then quick checks along the way. So I put these two images up on screen because this is a perfect example of when I did not do quick checks along the way. So this was a floral ring in Tinkercad that I did through my April online classes. The top pink ring was one that I just did as the demo, just to kind of like build my tutorial. And then when I went to see if if I could fabricate it, I realized, nope, I cannot. There's too many small details which cannot be fabricated. So then when I built my next one during the actual class that I gave live through YouTube, then I sort of took that into account. But I had basically finished this entire ring before I went to Shapeways, which is how I was fabricating this at the time, and did those sort of automatic checks and realized I can't actually make this. So I wasted, however much time that was, a couple of hours. So make sure to ask yourself those kinds of questions. And then this is something, again, very universal. You can apply this basic concept to all 3D modeling softwares that you learn throughout your career. And that is, make your model from low detail to high detail. So start with the largest volume. So in the sort of example of the skull ring, which is the image that you saw on screen when you first joined, this is sort of where we ended this last image that, looks a bit like a stormtrooper, a little bit less like a skull. But this is where we ended. And where I started was on the left side of the screen. So really building out detailless features. So placing the jaw bones, starting to build out sort of the face and the nose, the foundation of the sort of nose, the skull itself, right? And then the ring shank itself. And then sort of moving towards adding larger features, but still, less detail here, where I'm adding really contour, connecting some of the jawbone areas to the chin, putting in these sort of cutting tools to then cut out eye sockets, cut out sort of shaping into the skull itself, into the head. This is like the bulkiest, sort of most time-consuming part of the process. And then once I was happy, then I really went in and sort of featured out and detailed out by adding the nose bone, adding some of these, teeth and gum shapes in there. So this is something that if you learn this and you perfect this approach in Tinkercad, you can apply this for your, to any modeling software that you end up using. These principles remain the same and remain crucial. And then just to kind of wrap up with the skull ring, transforming your design. So the downside of Tinkercad is that you are a bit limited because this is an easy to learn software. And this can be a frustrating thing for anyone who is a pro or is quite competent in another more professional software, is that you don't have control over things like softening edges, or we call that filleting. It's really hard to build sort of organic shapes. And so for me, this was a personal challenge when I was learning Tinkercad to say, what could I do in Tinkercad that seems much less obvious or not possible? And the skull ring was a perfect concept because it's so organic, it's so recognizable, it's so soft, right? And none of those traits are naturally in Tinkercad. So what I did is, again, using Shapeways, I modeled the skull ring that you saw on the last slide. I then had it casted in brass on the left. I then used a Dremel with a flex shaft, which is just a typical tool that you would use for polishing, finishing as part of a normal jewelry fabrication process. And then, I polished it down, added the patina to really bring it to life. Now, what I would recommend, some of you are probably like, oh my gosh, she wasted so much metal, so much material doing this. I would never take this approach if this was gold, right? Or even sterling silver. Brass was fairly inexpensive, and I was trying to really limit the amounts of steps because I was teaching this class to adults. And so, if you were a professional jeweler or you're doing this in sort of more the right way of doing it, you would just print this in a castable wax, and then you would do all that sort of sanding and finishing, and then you would have it casted. Because I did really chip away and sand away a lot of the material, the metal itself, and to get from here to this sort of metal, middle, more softened image. So the one kind of pointer right there. So prototyping and production. So let's talk a bit about just wrapping all this up, and then we'll jump into the live demo. So if you are, I know that there was about half of you that are still kind of looking around at bringing 3D printing into your workflow, maybe new to 3D printing or new to Formlabs. So I wanted to just point out a few different resins that you would be interested in that would be beneficial for you. So grayscale resins. So this is our standard prototyping resin family. What you see in the image is the gray. There's also the black down there, and this might be white, I'm not sure, but we offer it in gray, black, and white. And this is I assume it's the most heavily used resin for Formlabs. I should actually look that up before I keep quoting that. But it is sort of our most common resin in terms of having wide span usage. And so if you were prototyping, sort of printing your own designs to review them or to review with a customer for fit, for overall aesthetic, you would likely use gray, maybe white, maybe black. Gray we find is the easiest to sort of read in terms of the small details. You can really see them clearly. And it's sort of our most commonly used resin. I, as a professional 3D modeler, jewelry designer, I used gray resin very heavily. If you do then jump over into production, we've got two castable resins. This is our castable wax resin in purple here, and this is what you would use to then run production. So you could print off your design in the castable wax resin, and then you could then yourself cast it or send it to your caster to go through that investment casting process. We also have high temp, which is used more on the manufacturing side to be, which can be used for medium temperature vulcanized rubber molding, if that's something that you're interested in as well. So I would point you there to start. In terms of Formlabs resin assortment. And then this is just a video that I wanted to show you of really, if you haven't seen Preform, you're not familiar with this slicing software. So this is Tinkercad that you're looking at now, which we'll be jumping into in a second. This is that skull ring that you saw on screen. So I'm exporting it. You can see OBJ, STL. These are common universal 3D printing file types. So I exported it as an STL. I'm then going to open it in Preform. So this is Preform. And for anyone who's new, we have this option of one-click print. So I've imported that STL file from Tinkercad. You can see it right there shown in previewing in castable wax resin. I click one-click print, and then what this does is it takes all the guesswork out. So it orients your part based on how it thinks it can be the most successful, or at least can be successful, and then supports it and orients it on the build platform. This is how a lot of users start when they're new to Formlabs and new to our printing technology. However, you will quickly find that you may want more control. And so what I'm doing now in this video is checking out where those supports are. And the supports are really there to anchor the part onto the build platform and also to provide physical support while it's building the geometry. So what I'm doing now is saying, you know what? I don't really want all of these support touch points on all of these highly visible, more valuable or priority surfaces. So I'm just going in and quickly removing all of them. These are just sort of previews of where each support strut or structure will attach to the model itself. I'm deleting the ones that I don't want just because I know that they may not be necessary, and I can sort of manually support myself. But then I'm going back in and saying, okay, oh, there's some highlighted areas in red that Preform is telling me you need to support this area, otherwise you can expect to have some challenges or some print failure. And so then I can go back in and I can say, okay, let me manually add where those supports will be, and I'm getting live feedback from Preform saying, okay, this is a more supported model. You should expect more success here. On the side of the screen as well, you'll see things like print time, layers, volume. If you would like to calculate how much this model will cost you in resin, that's a way you can do that by checking out the volume consumption. Preform is available for download even if you don't use our printing technology right now. So this is a great thing that we always recommend to customers to check out, to run their models through it, and really get a sense of what the costing is. And we tend to, we think that that can be very helpful when you're evaluating, a printer purchase. Okay, so let's move over to Tinkercad itself. So at this point, I am going to do a quick demo on how to do this ring. And so this is a ring that I fabricated for myself. I did this originally in Rhino, but then challenged myself to see if I could do this in Tinkercad. And this script ring concept is sort of a personal bestseller where people can choose their own word or name or whatever. So anyway, so this is the finished ring that we'll be doing. And so I'm just going to delete that and then walk you through it. So this is the Tinkercad interface. I'm not going to deep dive into all the tools. Really, your navigation is over here. This is it. This is your entire workspace. So you can see that it's very primitive, pretty simple, not a lot of complex tools here. You've got your shapes over here. You've got your sort of tools to modify and to manipulate your shapes up here. And so I do have an introductory class where I really just focus on walking people through the entire interface, understanding how to manipulate objects. That's on my YouTube channel, so I definitely recommend checking that out if you are looking to sort of start working in jewelry, especially in Tinkercad, especially for jewelry. So let me just kind of walk you through the process. So as I mentioned, you want to start with the sort of basics, right? Starting with less detail and moving to more detail. So I'm starting with the solid cylinder. I'm increasing the number of sides to sort of smooth it out. I'm rotating it. And again, I'm not going to go in super detail. This class of the script ring is actually on my YouTube channel. So if you want to do this, you could totally do it. It's like, I think it's like an hour and a half class. Okay, so the first thing I'm doing is starting by building my ring size. So my ring size is a size 6, and that is 16.5 millimeter diameter. So you can see that I can easily change the sizing of this cylinder, and then I'm giving this ring a 2 millimeter thickness. So that's essentially the hole that my finger will fit into for the ring. So I need to add wall thickness. So I'm going to duplicate this item. I'm going to resize it by adding 2 millimeters all around. So 4 millimeters total. So 16.5 becomes 20.5, and I'm keeping my width the same at 2. And then I'm going to change that to be a hole. And this is now what you'll really understand the power of Tinkercad and really how modeling software works generally. So I have a hole here and I have a solid here. When so I'm going to align these items so that I can guarantee that I've perfectly centered in here. And you can see they're perfectly overlapping. Now look what happens when I group them. The hole realizes its existence and cuts itself out of the solid. So now I have the basis of a ring shank. I need 2 of these rings. So I'm going to duplicate this, and I'm really just building at this point on the work that I've done. So I essentially have the foundation for my double finger or double shank ring. And I need to sort of add this little connection down here and cut away some of this material so that it's a little bit more comfortable on the finger. So to do that, I'm going to grab another cylinder. I'm just going to change the color just so that you can clearly see the difference in pieces. Increase the number of sides. Again, rotate that by 90 degrees. And I'm just going to start to sort of scale this down and then move it a little bit closer to make this next part easier. So I could now navigate to the front, toggle my view so I can get more of a sort of flattened view. And I'm just going to start to orient this. And so what I'm doing now is going to build the connection point for these rings. And I'm doing that by using arrows to navigate, kind of roughly centering this. I'm going to scale this back up a little bit. And what I'm right now, I've got my eyes on these 2 points right here. I'm just trying to basically get this pretty much right in line. And you can see it's a little bit, there we go. Okay. So this is what I'm looking for, this connection, this sort of nice tangent, smooth, continuous curve right there. So now that I've got that part in place, I need to build a smaller hole in the center the way that I originally did with the ring shanks. So I'm going to duplicate this item. Just going to move it out of the way so I can resize it. And I'm resizing it in the same way. I want it to be a 2 millimeter all around thickness. So I'm going to subtract 4 millimeters, so 3.9 and 3.9. And then I'm just going to go ahead and kind of drop this in here. I'm going to align these again to make sure that I'm perfectly centered. Grab those 2 objects, group them so that there's a hole in there. Make sure that's fully cutting. This item is fully cutting away through here. Oh, actually, I'm sorry. Now I'm going to resize this to be 2 millimeters. I'm going to align everything together only in the side view so that everything is flush. And then just go right back to my front view, make sure nothing has shifted, and I'm happy with that. So this just looks funny right now, right? So what we're going to do is now trim away some of this material. So I like the foundation of my double ring shanks and my connection part, but I need to cut away this material. So I'm grabbing a primitive shape. As a whole feature, I can always change it to be solid, but I know that I'm going to be using it to cut away, so it's going to be a hole. And then I'm going to kind of go back, drag it roughly in place, go back to my front center view, and then start to, again, align this up here. This time, I'm going to lift it off the work plane or off the ground because I want to actually use it to, oops, sorry about that. Use it to cut away. So I'm cutting away essentially all of this area right here. I'm cutting away all the orange. And what I'm looking for right now is that I'm cutting away, actually I've landed that pretty nicely. I'm cutting away everything up here. So once I'm happy with that, what I need to do is group these 2 objects together just so that they're treated as one object. And then if I group these with the box, I've cut that area away. So you can kind of see this taking shape now. So now I'm doing the same thing to right here because this is really just going to be trimmed away. So let's grab another box hole. Let's move it overlapping, go back to that front view. And this time we're going to scale this down. I don't need to cut so much. Drop it below because now I'm cutting all of this excess pink away. So that to me looks like it's going to do the trick. So let's grab the box hole. Let's grab this little pink ring or cylinder, group these together, and now I have my connection point. So you can see that this is really the foundation of how you combine primitive objects to to each other to make more complex shapes. So the last thing that I will do is grab all of this, and I'm going to group it all together so that this is now treated as one object, which you can see right there. And the last thing I'm going to do, so I could use Scribble to create that custom name if I wanted, where I'm literally just using my mouse to write my own name. And you can see how that translates to geometry. You can also import a sketch that you've scanned into the computer and turned into an SVG file. You can do that by clicking import. So that's another option as well. But for this, just to speed this up, I've already, let's see. I've already just prepared one right here. So I'm just going to move that in place. And then what I would go do to finish this, I would go in and sort of just trim away some of this excess so that you don't see that ring shank peeking out between the letters. I could trim that away. But that is essentially the basis of how Tinkercad works. So let's just move back over and certainly drop any questions in that you might have. I'll move back over to this presentation to wrap this up. So resources for learning. So Autodesk has a really great series of online resources where if you just want to sort of learn outside of the scope of jewelry, this is a great place to start. They have a series of just different little tutorials that show you how to translate, manipulate shapes, the sort of principles of combining and subtracting primitives together, which is what we were just doing. And then I'll also just point you back to my YouTube page, which I have these 5 tutorials, again, that I had done for the month of April. And you'll see that for, I think, 4 out of 5 of them, there are 2 versions of these videos. There is a full recording of the original live stream where I walk everyone through step by step how to build that ring. So you don't see it on the screen, but that script ring was actually the first of the series of classes. That tutorial that I just did in full was a little under 2 hours. So this is really where you could put this on the side and just kind of follow along and in real time. And so I'll really be sort of talking to the audience, explaining why we do things, the principles around it, and then I will demonstrate little segments of what I did very rapidly just now. I will break it down into very small bite-sized pieces where I say, okay, here's what we're about to do. I'll show a few steps, I'll delete it, and then I'll do it again slowly so that you can then follow along. So this is a great opportunity to build some of these different types of jewelry, that floral ring you saw early on, the script ring, a charm ring, a signet ring. That really show you a broad set of approaches and skill sets for Tinkercad. If you are really comfortable in Tinkercad and you just like a little bit of guidance or ideas for jewelry, again, for 4 out of 5 of these sessions, I have a quick guide that you can see down here, like a quick guide. And that's about, I think they're all under a half hour, where really you can just follow along rapid fire. So I don't really do a lot of like diving into the why. I'm just showing you just the steps. So you'll kind of need to pause here and there if you need to sort of catch up. But that's 2 options. So yeah, check that out, Liz Hill-Weicker on YouTube. And then before we jump over to Q&A, I will just mention a couple promos that we've got going. So Formlabs right now is doing a 30-day guarantee money back if you're not satisfied with your printer. And so really, it's as simple as it sounds. Try a printer for 30 days. If you really are not happy with it, no questions asked, we'll refund you and take that printer back. And then we also have an ongoing referral program that I wanted to point, many people who are Formlabs customers, I don't think know about this, where if we can generate a unique referral code for you, and if someone else in your network buys a printer, uses your code, they'll get a small discount as well, and you will get credit of $250 towards purchases towards materials and accessories. So just wanted to call that out to you. And then with that, we will move over to Q&A. So let me actually kind of keep an eye on this. So someone had asked about what the materials, I think this was the very beginning. So I think this was in reference to the skull ring on screen, and that ring was made in brass through Shapeways. And so just to kind of talk briefly to that process. So if you're a jewelry designer, you're looking to get into prototyping through 3D printing and production. So you would essentially do all your modeling in your software of choice. You would then prototype, or you set it up in preform the way that I had showed you with a skull ring. You would then print it in castable wax resin or castable resin. And then from that, you could take that item and send it to a casting house. Or if you have access to casting yourself, you would put that through a typical lost wax casting process or investment casting. We have a different burnout schedule than you would expect to find with more traditional waxes that you would use for hand carving. So definitely consult our website for that burnout schedule that you may have to pass to a caster. But really, you could then use that to cast any of the materials that you normally would, any of the metals. I specifically used Shapeways. At the time, I was not working at Formlabs, and I didn't have the same access to castable resins. And so I use Shapeways. There's quite a few different 3D printing service bureaus out there that will essentially do that whole process for you. So you would upload the design, you would then choose your material, and then they would take it through the rest of the process, printing it, casting it, polishing it, finishing it, all of that stuff. So the one on screen that you saw, the large skull ring was bronze, and the small skull ring was brass, just solid bronze, solid brass. And then someone's asking as well about the on-demand webinars. So yeah, so we have been doing a series of CAD demos. This is one of them: Blender, 3Design, Tinkercad, Rhino, ZBrush. So Blender was, I think, 2 weeks ago. And so if you go to formlabs.com, there is a section that, like right on the main header, there's Formlabs' COVID response, and then there's also Formlabs Comes to You. And if you go to the Formlabs Comes to You, you can sign up for upcoming webinars, and you can also look at the history of them. They do take a few days to be uploaded. So like this one, if you're trying to rewatch it or someone else is watching it, it may not be available until end of week, but it will be there. And I think you just submit an email and you can get access to it. So yes, you can certainly watch that. And then someone is asking about using gray colored resin more often. Why that and not castable wax? That's a great question, Nancy. So the gray resin, so first of all, it's less expensive, and so quite a bit less expensive. And it's our lowest tier in terms of price point. So this is a resin that is really optimized for surface finish, for ease of review, ease of sort of readability of the model itself. And so gray resin is really meant to be the prototyping resin. So whenever we're modeling something, that whether it's now at Formlabs or during my time at Coach, at Tapestry, we would always do the bulk of our prototyping, our 3D printing, in gray resin. And the reason is just that was sort of a common practice for us. Everyone sort of knew that when they were holding one of those, it was a 3D printed part, they were reviewing it. We wouldn't have them necessarily review in castable wax, mostly because it's more expensive. It's meant for production. It's also a lot darker. And so some actually can find that it's a little bit challenging to view small details because it's so dark, and the preference was typically gray, and we find that to be pretty commonplace. But if you decide to go to print a production, just pull the build platform out of my printer. So if you decide to really fill up the build platform full of production pieces, and then that is going to then go to a casting house, you would want to print that in castable wax. You cannot cast from gray resin. You can cast from castable wax resin. So yeah, so that so far is the questions. I will jump into the chat to see if there's anything specific. I think I answered the recorded webinar. Yeah, okay. You're welcome, Nancy. Okay, so I will just stick with this another minute or so, and then if anyone else has any final questions, certainly reach out. Otherwise, this concludes the presentation. And oh, I will just again plug while I'm waiting for any additional questions. So next week's panel for, so from education to fabrication, the professional's guide to 3D printing. So we are gonna have two guests from Rio Grande, which is a jewelry supply based in Albuquerque, New Mexico, that I've actually been to personally. It's a wonderful facility and an amazing team of, I think they're a 80, I think it's an 80-year-old jewelry supply company. And they're experts in 3D printing, in traditional manufacturing processes. So just a wealth of knowledge. And then we also will be pairing them with two different people from GIA, which is the Gemological Institute of America, that I believe is over 90 years old as an institute, and they are CAD teachers. So I will be moderating a panel between the four of them where we will really be talking everything from education, to intensive workshops focused on, what is the sort of future of jewelry? How do you get into CAD? What is sort of the softwares out there? What's the learning curve like? Really, if you are, this is just going to be an amazing resource base. So I invite all of you, if you are considering venturing into the jewelry industry, if you are a jeweler and you're trying to sort of modernize and get into the digital side of manufacturing and of design, if you're looking to know where to take courses, whether it's for a continuing education program or just sort of intensive learning workshop style, we'll go through all of that. And I expect to have a lot of big attendance and a lot of really specific focused questions. So certainly jump back for that. It's going to be great. That's next Thursday, same time, noon Eastern time. And then someone is asking again, just where we can view the webinar. I see that some people maybe jumped in a little bit late. So this webinar, I think everyone who has registered will get an email with a link to view it again. If you had missed any part of it, I think that will come out in a couple of days. This should be up on the website, but all of the Formlabs Comes to You series, including all of the June Jewelry Month content, which there's a lot and there's more to come, even into July and even into August. Will be available on demand, and also just kind of keep an eye on formlabs.com in the Formlabs Comes to You section, where we list every week. There's like at least 2 or 3 different pieces of content that go live, like this one. We'll have next week's listing up. I'm not sure if it might be the end of this week that we list it. So it's all there though. Yeah, okay, I think, let's see here. Another question. So someone is asking about having a Form 3 and having some issues with the thickness of the letters and the rings. And so, without knowing what size that is, I would first just say it's kind of, I don't know if Camilo, if you can share what the thickness is. The printers tend to do pretty well with fine details. When you have issues with things like, thin walls, so if you've got letters on a ring, it's probably very small. They could either be recessed, so engraved or sunken, or they could be raised. 2 things can happen. If they're very thin letters and they're sunken or engraved, resin can get trapped inside there during the printing process. You might play or sort of test with different orientations of the part. So having the letters facing straight up, you might try that. You can sometimes get a different result that way. If the letters are raised and they're very thin walls, it could be that they need more support. Or again, you may not be able to support them because they're so thin. But I would say generally when you start to get under like that 0.5 millimeter thickness, whether it's sunken or raised, sometimes orientation on the build platform can really you know, can really be crucial. Okay, so you say 0.35. Yeah, so when I used to print back at Tapestry, we tended to expect when you went under 0.5 millimeters that sometimes it wasn't always going to be, it wasn't always going to come out clearly. But I would say, so if there's any room to increase those, you might try that. And if not, before you do that, you might try different orientations where you have the actual ring, the shank, you know, standing really like, you know, really like this, right? As compared to like at an angle. You want to really try and stand it up the way as if you were displaying the ring standing. You could try that. That might give you a different result. Okay, so with that, I'll just double check the chat again. Oh, and it looks like we have a panel. The link for the panel is in the chat, so be sure to grab that if you're trying to link to it quickly. Thanks, Diana. Okay, so let's see. Oh, what thickness do you recommend? Yeah, so Camillo, I would try 0.5, just a little increase to see if you can get a better result. That's usually kind of like the border of where things can get a little bit challenging. So try 0.5 and see if that gives you a better result. Okay, well, thank you so much, everyone, for joining me. I hope this was helpful, and definitely would love to see you guys again at the panel next week, which is I'm so excited for. And do be sure to check out any other demos that you may have missed. So thank you so much. Thanks for joining us. Have a great day.